Good. All right, so where are we at? So order from least to greatest. Check your answer using fraction tiles or number line. Why don't you bring your fraction tiles over? Okay. Perfect. All right. It's good to, I mean, I know it says in here it wants you to try to do, oh, don't do that yet. That's not your work. We may not have to do anything. Don't erase until you know for sure. All right, so let's see what we have first. Well, you did this one here, so let's look at this one. So we have 3/4, 2/3, and 7/8. Why don't we make those? Let's make like 3 lines. One that has 3/4, one that has 2/3, one that's 7/8. Tell me why you thought what you thought first.
So because I thought that 7/8 would be the biggest one because there's 8 pieces and 7 are like colored in.
Okay.
And then I thought 3/4 would be a big one because there's 4 pieces and 3 are colored in. And then this would be the least one because there's only 3 pieces and 2
Okay,
are
so you were looking at which number?
The
Here,
denominator.
The denominator. Okay. Did you try to make common denominators yet?
No.
Okay. Why do you laugh? Because that's what you did up here. Now we're just looking at 3 numbers. But yeah, why don't we go ahead and do that? Make your tiles. I think that using these resources, sometimes we get, especially if we're really good with math, we can just kind of do it in our head and get it done with. But sometimes seeing it too helps us later down the road. So always make sure you check your answers there. So you were looking at the denominator. How many more do you want? Just a couple more weeks. What's it called? Thirds, right?
Yeah.
Flags.
2/3.
Oh, you need 2/3. Okay. All right. So let's look here. Oh wow. Your theory definitely works. So if you think about, and you definitely numbered it, but I really want to think about.
Right? Like, I didn't understand. Like, I tried to understand these.
I see that as erasing. So
Yeah.
like you started to think through. Let's first explain this, and then yeah, we're gonna go back up to this.
Yeah.
This idea of the denominator being big, because the other pattern. Look at these 3 fractions. What's kind of the pattern that you see with the relationship between the numerator and the denominator?
Kind of like 1 or like a couple.
They're 1 apart from each other. 2/3, 3/4, 7/8. So we know that they're more of the pie, more of the pizza. But you brought up a good point when you said this is the bigger denominator. And so your pieces, like you need more pieces to do that. All right, so your theory stands for this. And so let's keep that in mind. Do we see any other patterns like this anywhere? Let's see.
Kind of like this one, but this is all thirds, but this is like.
Oh, so what's the same here?
So all the numerators.
All right, so let's use tiles to see what happens when the numerators are all the same, how we order them. So we need tens. I'm just going to take these out. 10s, 5s, and 4ths, right? All right, so let's get our 10s. And let's see what happens when the numerator is the same. Because I bet we could kind of like make a rule for it. Like, oh, when the numerators are this. What does that mean for our numerator? All right, 3/10, 5. It's really different than 3/4, huh?
Yeah.
All right, now 3/5. The green ones. What I like about fractions is like you have to look at the numerator and the denominator. Like you can't just look at one or the other. All right, so let's see what you thought. You said 3/4 was bigger, then 3/5, then 3/10. What does it tell us? I want you to think through. So we know the piece, the part of the whole is the same. So really, what did we have to look at to figure out?
Is the denominator.
The denominator. So because our numerator was all the same, what can you tell me about the denominator here?
The denominators.
If we made a
it's
rule.
1 apart. So you can't just look at like if they're all the same number, you have to see
right,
like
so
10.
if I have the same numerators, if my denominator is a small number, what does that mean versus if it's a big number?
If it's a big number, it's small.
It's going to be a smaller fraction.
Yeah, and if it's a small number, then my fraction is going to be bigger.
It's interesting, isn't it? And you see how we can see it better this way too. All right, are there any other patterns on here that, I wonder what would happen.
Maybe this one because it's 5, 4, 3.
Okay, which was
1.
simpler. Oh, that's interesting. All right, let's look at that. Let's make that one too.
3.
Alright. So we got a lot, I mean, it's an interesting pattern, but I don't know how much it tells us about this. Whereas this one tells us more, doesn't it? What happens if all, and then obviously if all the denominators are the same, how do we order it if all the denominators are the same? If I have, how about I make, let's write down, if I have 2/6, let's do it just like maybe right over here. If I have 2/6 and I have 1/6 and I have 5/6, how do I order that? What's my pattern there?
Well, so the smaller numerator, so this one was bigger. So the bigger numerator would be the smaller. Well, would be, so the bigger,
I don't have it perfect, obviously because I don't have enough tiles. So if I was to say, okay, put these in order. 2/6, 1/6, 5/6. What would be first? What would be the smallest?
1/6.
How come?
Because there's 6 pieces, but there's only one.
Okay.
colored
What's
in.
next?
And then 2/6, and then 5/6.
Okay, so if our denominators are the same, how do we order our numerators? Least to greatest. Exactly.
Or greatest to least.
Or great, yeah, depending on how. Okay, good. Nice. All right, so which one do we want to look at up here? Pick one.
That's kind of stuck on this.
Okay, so we have 2/3 and does that say 6/9? I'm upside
Yeah,
down, and that's a weird
6/9.
number. Okay, so our goal here. What did we do over here? What was our goal? To do what? To
So-
find what?
To find if it's bigger or the common multiple.
So we wanted to make our denominators the same.
Yeah.
Okay, so how can we make our denominators the same? We have to use our multiples.
So it would be 3, 4, 3, 9,
Good. All right, next one.
18.
Perfect. Do we have anything similar?
9.
So our 9. So what is that 9 going to represent now? What are we going to use that 9 for?
So this would be times 3.
Mm-hmm.
This would be 9 times 3 equals 6.
All right, so what do we
So
know?
it's equal.
It's equal. So you were right.
Okay.
Nice.
And then this one. So I tried this one, but I didn't really
Well,
understand.
let's list our multiples. That's where we need to start.
Because I tried and I just did 4 multiples,
Well,
but
What do you think?
go more.
All right, why don't we do more? All right.
I'm Anjali's sister.
I know. You tell her that I said hi. I sometimes see her when I'm at Red Lane, but I haven't seen her in a while.
Okay, so what do you need to turn the other cubes?
12.
You need to turn them into 6. So you know how to
So there's still 9
do. Keep going. Sometimes we take a little while.
This would be. But this is uneven number. This is
Okay,
1,
but
2, 3, 4, 6, 6, 7.
okay, but we know that both of those numbers go in because here it was uneven. It only took us once to get there, and it took us 3 times to get there. Okay, so we're not. It doesn't matter how long it takes you to get there. It's just can we get there? So what's going to be our new denominator?
So 30.
Good.
So now this would be times 6. That is 30 times 6 equals 18. Times 5 equals 30 times 5 equals 20. So this one would be this.
Exactly. Is that what you had before?
No, I hadn't thought of it.
Ah, got it. All right, good. All right, you work on these 3. If you want to take these, take them. I think that it's nice to use that visual, so put these away. And keep thinking through these patterns. I think that's something that's important to fractions is understanding how they work by using patterns, by seeing those patterns, and making these different rules. All right, cool. Hey, Grace. I have that sheet that I keep forgetting about. Thank you. Do you still need help?